Hi, today I want to take you through a real case of integrating Genum with external orchestrators, and in this demo we'll use N8N as the example platform. Let's start with a simple explanation of what Genum is and why it matters. Genum is a PromptOps Framework. In practical terms, it takes the logic of your prompts and removes it from the live runtime. It gives you the ability to debug and adjust that logic in complete isolation, and then, when you're ready, to reintegrate it back into the runtime without breaking your live processes. Genum AI effectively draws a boundary between your execution environment and your business logic. The easiest way to imagine it is as a CI/CD system, continuous integration and continuous delivery, but designed for prompts instead of traditional application code. For today's session, I'll be using N8N as the orchestrator, and to make the concept very clear, our use case will be a single GenAI call. We will keep things simple. We'll use the built-in chat node and chat widget inside N8N. The task is to generate actionable items, things like to-dos or follow-up tasks from a meeting summary. This is a scenario you see all the time in real AI tools. Products like Note-Taker, Firefly, and other meeting assistants. In those tools, the prompt is effectively the container for your business logic. It's where the rules live. It tells the AI exactly how to behave and what kind of output to produce. And with Genum, we recognize a strong trend in the industry. More and more of the critical business logic is shifting into the prompt itself. As AI models become more capable, the prompts inevitably become more complex and dynamic. Now, let's come back to the live demo. Inside N8N, we begin with the OpenAI node. Here you can directly write your prompt and execute it. When you are working with a single use case, everything appears fine. You run it, the output comes back, and it looks good. But as your application grows and becomes more complex, this approach quickly reaches its limits. It becomes harder to maintain control over the prompt logic. And when you make changes or updates to that prompt later, you have no certainty that it won't break other flows, because there's no built-in regression mechanism to tell you that everything is still stable. That is why we are taking a methodical approach today. First, we're going to verify that the initial setup and prompt work correctly in N8N. Once we are confident the flow runs as expected, we will move forward and port that exact same prompt into Genum. After confirming that the N8N flow works, I copy the prompt from N8N into the Genum platform. Then, using the AI assistant in Genum, I generate a structured prompt specification. The result is a clear, well-defined prompt spec that can be versioned and managed independently. At this stage, I can take the exact same use cases we just ran inside N8N and run them directly through Genum. This is how the standard workflow in Genum looks. First, you create your prompt. Let's call this one Task Generator. You test and validate that the prompt works as intended. Then, you save a test case. Saving a test case means a human operator visually verifies the output, confirms that the input and the output meet expectations, and then locks that as a reference for future checks. Once the prompt is created and validated, you have two options for using it. You can either upload it to an external tool or orchestrator, or you can call it directly through Genum's integration layer. In our demo, we'll go with the second approach. We have the prompt in Genum, and now we want to connect it to N8N. To do that, we add the Genum node into our N8N flow. Genum offers two node types for this, run prompt and get specific prompt. The second one, get specific prompt, is mainly used for agentic AI patterns, and we won't use it today. What we need here is run prompt, because it effectively replaces the OpenAI node with a vendor-agnostic Genum execution node. Inside this node, I select from list and pick our task generator prompt from the drop-down menu. With that set up, we're ready to execute the flow. When I run it for the first time, I immediately get a 404 error. That error is actually informative. It tells us the prompt isn't available to Genum yet. Why? Because it has not been committed. Until a prompt is committed, there is no productive version that the API can load. So I perform a commit. After the commit, the prompt receives a productive tag. I run the flow again, and this time the Genum execution node runs successfully. Next, I parameterize the node input using the incoming object tree from N8N, save the flow, and rerun the exact same test. This time, I can see that the prompt is executed externally via Genum, which means that all the business logic is now officially offloaded to the Genum platform. At this point, the benefit becomes very clear. In Genum, I can see all executions of the N8N flow. I can navigate into the logs and see every API call, the complete configuration, the input and output data, and even the cost of each execution. And here's the really useful part. Directly from any log entry, I can create a new test case with pre-filled parameters and inputs. Now, let's dive into why test cases are so helpful. Imagine that we run our tests and 2 of them fail. I open one of the failed test cases and compare the latest output to the expected output. For example, maybe the expected output has 3 items, but the last run only shows 4. That's a clear indicator that our prompt logic is unstable. When this happens, the prompt engineer or operator reviews the inputs and outputs and tries to understand the inconsistency. Then they adjust the prompt and rerun the test. Looking more closely, we might notice something like follow up on clause 7 concerns in the output, or we might see review vendor contracts. These 2 outputs just informative. To fix this, we tune the prompt with an instruction such as please only include clear and agreed upon action items. Skip any items that involve unresolved conflicts or lack explicit agreement. We update the prompt, rerun the test case, and now it returns the correct number of tasks. We switch the test from strict assertion to AI assertion. AI assertion allows logical validation instead of character-by-character comparison. It can ignore formatting differences, use whitelists or blacklists, and let you define the comparison logic in a more human way. After switching to AI assertion, the test passes. With this approach, once your prompt is stabilized in Genum, even complex inputs that used to produce unpredictable outputs now result in consistent, reliable answers. And whenever you need to change your data structure or update your business logic, you can rerun your test suite to verify that all critical scenarios still behave as expected. This process is not hypothetical. At the beginning of 2024, we went through the exact same challenge. We were using an orchestrator to pass incoming supplier emails, and after 3 months, we realized that unpredictable outputs were costing us real money. By moving the logic into Genum and stabilizing it with test cases and regression checks, we were able to complete a large-scale business project successfully. Now, we're making this platform available to you. Genum comes with FinOps features, role-based access, and full integration support. We will keep evolving it because we are convinced that predictable, controlled GenAI is the foundation for true business adoption. And that's it for today's session. Thank you so much for watching and stay tuned. More advanced scenarios are already on the way.